Systems of linear equations in several variables, part 1. We've been looking at solving systems of linear equations. What we're looking at in this section in particular is a linear system of 3 variables. When we have a solution, we're looking for that ordered triple, that value for x, y, and z that satisfies each of the equations that we're given. There may not be a solution, there may be many solutions, so we want to keep that in mind. When we're solving, we may end up with one, none, or many solutions. Methods for solving. We have Gaussian elimination, that in our calculator is REF. With Gaussian elimination, though, we have to use back substitution in order to complete the problem. We end up with that diagonal of 1s with 0s below. We get z is 3, so I'm going to plug z is 3 to get y. Now we know y and z, so we plug in to get x. And so I could use Gaussian elimination, RREF, with back substitution, but a better and more efficient way is what we've talked about, which is Gauss-Jordan elimination. Gauss-Jordan elimination just takes us directly to the answer with RREF. Okay, this is going to be the only way that we will be solving our system of equations. It takes us directly to the answer. We don't need to do anything but interpret our results. Okay, so we've got REF, Gaussian elimination, our preferred method, our REF, Gauss-Jordan elimination. We could also use these steps and solve by hand, but we're not going to look at solving by hand when we can get our calculator to do the work. Let's look at our first example. Find the complete solution of the linear system, or show that it is inconsistent, or show that either find the complete solution or that it doesn't have a solution. Okay, so first thing we want to do is form our augmented matrix. So we have our x, y, and z. X is 1, and we're looking at that first row. In our first row, let's see if we could write down coefficients. For our first row, coefficients are 1, -2, 3, other side of the equal sign, 10. Next, we'll look at the second row. When we have a variable missing, we just put in a 0. So that would be 0, 3, 1. That's equal to 7. Looks like I need a negative here. And then our last row would be 1, 1, -1, and 7. We should be able to go from the augmented matrix to our system, from our system to an augmented matrix, or any equation from our augmented matrix. Okay, so from here, we're going to get this put into our calculator. So we're going to say second matrix. We'll go over to edit. This first number is always how many rows there are. Then we're looking at how many columns there are. We have row 1, row 2, row 3, so that would be 3 rows. Columns, column for x, column for y, column for z, column for the other side of the equal sign. That would be 4 columns, so that would be the size or dimension of our matrix. Okay, so let's put that in. So 3, enter, 4, enter, and now we want to put in our matrix values. We'll look at row 1. Okay, so for row 1, we have 1, enter, -2, enter, 3, enter, -10, enter. Okay, next row, 0, 3, 1, 7, 1, 1, negative 1, 7. Okay, let's try that again. So we're going to say second matrix, edit. Okay, so 3 by 4, 1, negative 2, 3, negative 10. So that was good. 0, 3, 1, 7. That was good. 1, 1. Here we will go, what, negative 1, and then 7. Okay, so we're going to hit second quit. That takes us to the home screen. Second matrix. We put everything in A, so I'm just going to hit enter twice. That allows A to be brought up, and then I can do a visual check. Did I do everything okay? Did I put in the entries right? Looks good. Second matrix math. Up arrow gets us to RREF just a little bit quicker. We hit enter, and then which matrix do I want to RREF? Which matrix do I want to perform Gauss-Jordan elimination on? That's matrix A, and there's our solution. Okay, so we know we're going to get a solution. We know we're going to get a solution because we see that trying to get clicked off of this screen. There we go. Okay, so I know I'm going to have a solution because I have ones on the diagonal. I have zeros below the diagonal. I have zeros above the diagonal. So I know I'm going to have a solution. Okay, so let's get that solution read. Here's the x coefficients, the y coefficients, the z coefficients. And what this first row says is x plus 0, y plus 0, z. In other words, x is equal to 2. Okay, the second row, let's look at what this one says. 0x plus y plus 0z, or y is equal to 3. And then our last row, 0x plus 0y, those x and y's get canceled out. Z is equal to negative 2. So our solution, remember, is an ordered triple. X comes first, y comes second, z comes third. That's our ordered triple. X comes first because that's the first listed in the equations. Y second, z third. There's our solution. Okay, so let's look at our next example. We set up our augmented matrix, which we already know how to do. Negative 1, 1, 4, row, column 1, 2, 0, negative 2, 5, negative 2, negative 11, 4, 0, 2, and we're ready to put that into our calculator. We say second, matrix, edit, 3 rows, 4 columns, and then our entries, I already put them in there. We're pretty good at doing that by now. Now we want to say second matrix math, RREF, second matrix A. Okay, once we RREF matrix A, now we're ready to read our solution. These are coefficients for X, coefficients for Y, coefficients for Z, and the other side of the equal sign. Now notice we don't have that diagonal of ones. So this is either no or infinite solution. Let's see which one we have. We'll concentrate just on this last row. We have 0x plus 0y plus 0z. That's going to be 0. Other side of the equal sign 1. We know that 0 does not equal 1. Anytime we have a false statement, we say there is no solution. There is not an x, y, z that satisfies all 3 equations at the same time. Okay, we're ready for our last example of part 1. Again, we have our system of 3 equations, 3 unknowns. We form our augmented matrix. We go to our graphing calculator. We enter in matrix A. We RREF matrix A. Again, no, I'm not going to get a solution. I know I'm not going to get a solution because we don't have that row of diagonals. Okay, so in this case, what kind of solution do we have? If again we look at that last row, we get 0 equals 0. This is a true statement. In the last statement, we said 0 doesn't equal 1. That's a false statement. False statements say no solution. But true statements, 0 does equal 0. That's our infinite solution. Okay, so let's write out our infinite solution. When we look at our infinite solution, we're still going to come out with an ordered triple, an x, y, z. Okay, looking at this first equation here, we have x minus 7z, that's my letter z, x minus 7z, x minus 7z is equal to 1, or x is 7z plus 1. Okay, let's look at the next equation here. We have y minus 4z. Y minus 4z is equal to negative 1, or y is equal to 4z minus 1. So we'll fill that in the y position, and then z is called arbitrary. If you were to give me a z, I could give you a solution. If z is 0, then we have 0 plus 1. We'd have 1, negative 1, 0 as a solution. If you said z was 5, then I'd have 36, 19, 5 as another solution. Whatever z you give me, I can generate an infinite number of solutions.